So graphing other trig functions. The first one they talk about is the tangent function. They give you all the information on the left. Real numbers, x cannot equal pi over 2. That is the domain. So the domain, we've done this, right, where you had to tell me the domain. X is an element of the real numbers. X cannot equal pi over 2 plus n pi. That means any multiple of pi over 2, right? It cannot be pi over 2 or any half circle of pi over 2. So pi over 2 or any half circle of pi over 2. Why can't the tangent equal pi over 2? Pi over 2 is on your unit circles, your top, right? Your top one and your bottom one. Tangent is sine over cosine. It is your y over x. Your x value at the very top is 0. Your x value at the very bottom is 0. So a tangent at pi over 2 has 0 in the denominator. That is why you see this dashed line. That is a vertical asymptote, right? Remember that term, vertical asymptote. You have a vertical asymptote at any pi over 2, 3 pi over 2, or any circle thereof, all right? And so that's why this function does what it does. It goes infinitely one direction, infinitely the other, and then it jumps over every pi over 2, all right? The reason it goes infinitely is because you can have an x or y that's any number, right? But sine is limited. So because sine is over a hypotenuse, you're limited to the 1 and -1 bounce unless you have some alteration to it, because your hypotenuse is your longest side, and so you'll never go above 1 and you'll never go below -1. But tangent's not like that. You can have any ratio between the sides of the opposite and adjacent side. And so you can have one that's longer or one that's shorter, and it's going to be really an infinite direction there. Your intercepts will occur at your zeros and your pi's for just a standard one that's not shifted. And this one is symmetric to the origin. So you can see that if you were to flip-flop it across the origin, it would be the same exact function. All right, that is your tangent function. All right, the period of a tangent function. The tangent function actually is just your pi, whereas your sine does one full cycle every 2 pi. Your tangent's every pi. So you'll notice, like on your unit circle, that you saw a symmetry between the quadrants. Your tangent will do that. Your tangent will repeat every pi. And so that's why you see, like, from first and fourth quadrant will be a full cycle, and then second and third quadrant would be a full cycle on your unit circle for your tangent. And so that it repeats every pi, not every 2 pi, like sine and cosine. Cotangent. Cotangent looks almost identical, all right? The difference is the direction that it is going, because if you think about it, you're just flip-flopping your x and y. So it is almost the mirror image of it. So if you were to take every x and y and switch it, that's what happens from tangent to cotangent. If you recall in right angle trigonometry, your cotangent and your tangent are reciprocals of each other, right? And so that's what happens here. You have the reciprocal function. You'll also notice where your zeros are. Your zeros now occur at 0 and pi, all right? Because this is x over y, not y over x. So then wherever you have a 0 in your y is where you're going to have a vertical asymptote for this guy, all right? And then your cosecant and your secant, cosecant and your secant. All right, this is also a function that repeats itself. These look like little parabolas, right? And they flip-flop across. You'll notice that your cosecant, which is your reciprocal of your sine, on the 0 and on the pi has a vertical asymptote. This is where your sine value is 0. So it's going to have the same restrictions as your tangent, where your or as your cotangent rather, where your sine values are 0. This secant function, which is the reciprocal of your cosine, that's going to have the same restrictions as tangent, where your cosine is 0, because cosine is, again, on the bottom. But other than that, they look like little parabolas that flip-flop across the axis there. All right?